Today's lesson is about making measurements, getting the proper digits with that measurement, and doing a metric conversion once it's done. We'll start off with the triple beam balance. Triple beam balance has 3 beams, all measuring the amount of mass of a material once it's balanced. We see that it's magnified here, so let's take a look at it. We are starting with 350, and it looks like 4. So we can record 354. And now we're down to the tenths plates. So it looks like 5, 6. So 354.6. Now we know all of that for sure from our piece of equipment. We need to guess the last place. So I look, and it looks like that's right on the line. So I'm going to guess the hundredths place. And since it's right on the line, I'll make that a 0. So 354.60 grams. That's the most digits you can get from your piece of equipment. This last decimal point is guessed, so is assumed to be the uncertain digit. Now let's convert that. Let's convert that to kilograms. So how many kilograms is that? Let's look at our stair. We're starting at the base since we're grams, and we need to go 1, 2, 3 jumps to the left. So 354.60. Let's go 3 jumps. 1, 2, 3. We'll record that as 0.35460 kilograms. Notice how I kept the 0. I did measure it before. It was guessed, but I did measure it, so I'm going to keep it when I do my metric conversion. Let's try a liquid measurement. Remember, liquid measurements, we measure the bottom of the meniscus. The meniscus is that curved surface because water will stick to the sides of the graduated cylinder. So we're reading the bottom of it. We look, there are 10 lines between the 50 and the 40. So therefore each line must be 1 milliliter. So let's count. That's 40, 1, 2, 3. So I know I have 43 for sure. So I can measure definitely out to the ones place. So let's guess the tenths place. It looks like the line is right on the line for the graduated cylinder. So I'm going to write that as 43.0 milliliters. That's our uncertain decimal point. We have guessed it, but it's part of our precision of the measurement. Let's convert that to deciliters. So how many deciliters is that? Well, let's look at our stair step. We're starting at milliliters, and we're going to go 1, 2 jumps to the left. So I'm writing 43.0. I will then go 1, 2 jumps to the left. That's 0.430 deciliters. Notice again, I am keeping the 0 that I measured before. We don't want to lose any precision of our measurement when we are doing a metric conversion. All right, what about length? Well, length we use, meters, centimeters, millimeters, those kind of things. So we have this bolt here, and we're measuring the length of it. So it looks like we're starting off with 6 centimeters, and let's see what's different from that. And it looks like we're halfway between the 5 and the 7 here. And there are 10 lines in between each, so each one is worth 1. Okay, so it looks like we have 6.5 centimeters. Now I can get that definitely from my piece of equipment, so I need to guess the next decimal point. It looks to me like the end of this bolt is right on that line. So I'm going to go 6.50, and I'll record that as centimeters. Let's convert that to microliters, or micrometers. So how many micrometers is that? Well, go back to our stair. We're starting at centi. So we're going to go down 1, 2, 3, 4, and we're going to the right. So I'm going to record my 6.50. I'm going to go 1, 2, 3, 4, and I need a couple zeros there, so I'll go 6, 5, 0, and I need 2 more zeros. And I'll record that as micrometers. So let's trace that. 1, 2, 3, 4. Notice how 2 zeros appear because we need placeholders to hold the place for that. Now, because that 0 was measured, I am going to put a line on top of that so I preserve that. I'm telling everybody that this 0 was part of my original measurement when I put that line on there. Okay, so that looks good. And let's do one more. This is a thermometer. When I'm looking at this, I go 25, 30, 35, and there's lines between each representing each degree. So I know that each one of these lines is worth 1. So let's see where we're at. So I've got 25, 26, 27, 28. So one more time, I can definitely read from the line there that we're 28. So I need to guess out to the tenths place now because I can definitely read the ones place. And one more time, it looks like it's right on that line. So I'll write 28.0. And I'll just record this as degrees. We don't know if it's Celsius or Fahrenheit. It looks to me like it is Celsius because if I look 0 here, then -5, -10. So I guess I'll just assume that. So degrees Celsius there. And again, that's how you make measurements to get the most precision. Precision means how many decimal points you can get off your equipment. The last digit is always assumed to be estimated.